Let's continue discussion about the numerical methods now. So after the bracketing method or bisection regular fallacy, so the next method that we can use, okay, to solve the roots of a given equation would be the open method. Now, so under this, we can use either the secant or the Newton-Raphson. Okay, so let's try to derive first the formula for the secant method. So the secant method can be derived from the geometry, no? So let's say initially this curve represents the behavior of a given function. And we're given here the 2 points x. We can label that as x sub I minus 1 and x sub I, no? So from that, we can be able to determine, okay, the value of f of x sub I minus 1 and f of x sub I, no? By simply substituting these two values, okay, to the given function. And by connecting these two and projecting these 2 points, okay, we can have an intersection between this line and the x-axis. So the point of intersection, we can label that as x sub I plus 1. Okay. So from the geometry, from similar triangles, we can be able to generate this equation. So this segment AB, okay, over this AE is equals to this segment TC over DE, no? So of course, we can be able to rewrite this equation as in this form. So since AB is the same as the value of f of x sub I, and AE is just the difference, okay, between the two x here, x sub I minus x sub I plus 1, no? And of course, CD can be expressed or similar or equivalent to f of x sub I minus 1, and DE is x sub I minus 1 minus x sub I plus 1, no? So just isolate this x sub I plus 1, okay, can be able to derive this formula, no, for the secant method. As you can see, this is similar to the previous method that we discussed last time, which is the false position. Just set this x sub I minus 1 as A, and this b as x sub I, or this x sub I as B. So if you try to recall the formula for x sub n, this is B minus f of B times B minus A over f of B minus f of A. Okay. So yung algorithm for the secant method, okay, step 1, we need to calculate the next estimate, okay, of the root. Okay, so of course, assuming that we're given here the two initial guesses, yung A and B natin, no, for the range. So this is the formula. Then we can find the absolute relative approximate error by applying this formula, though, for percentage error, x new minus x old over the x new. Take the absolute value times 100, no? Step 2, find if the absolute relative approximate error is greater than the stated relative error tolerance. Okay, if so, we need to go back to the previous step. Otherwise, we need to stop the algorithm, no? Also, we need to check if the number of iteration has exceeded number of iterations stated in the problem. So example. So let's say you're working for the down the toilet company that makes float for ABC commodes. The floating ball has a specific gravity of 0.6 and a radius of 5.5 cm. No? So you're asked to find the depth to which the ball is submerged when floating in water. So we're given here this figure. We need to find this x, okay, in depth, which represent the depth. And we're given here the variable r, which represent, of course, the radius of this ball. No? So continuation, we're given here the equation. So that gives the depth x to which the ball is submerged underwater. It's given by this equation, no? Or function. So we have to use the secant method to find the roots of the equation. Of course, to find the depth x to which the ball is submerged underwater. No? So also stated the problem that we need to conduct 3 iterations, okay, to estimate the root of the above equation. Then find the absolute relative approximate error in the number of significant digits. No. So let's see, we're also given here the possible range, no? So graphically, we can see here that between 0.06 to 0.08, okay? So yung root natin lies between these two interval, no? So let's say from this given problem, we're given here the value of the 2x. We can label that as x sub -1 as 0.02 and x sub naught as 0.05, no? So of course, we can estimate the root, okay, from this 2 by applying the formula natin. Just set the I value to uh, 0. Okay, you can generate this x sub 1 equals x sub naught minus f of x sub naught times x sub naught minus x sub -1 over f of x sub naught minus f of x sub -1. Okay, so just substitute since we're given here the x sub naught, x sub -1, and of course you can determine f of x sub naught by substituting this 0.05 to this given function. Okay, similarly, we can be able to determine f of x sub -1 by substituting this 0.02 to the given function. Okay, so this will give us the next possible value of x as 0.06461. No? So this is the first iteration. So of course, it's also stating the problem that we need to calculate the percent error. No? So this is the formula, x new minus x naught over x new times 100. Okay, so this will give us around 23%. No? So graphically, we can represent, okay, yung x sub 1 natin. Initially, we have the two uh, values of x now, yung 0.02 to 0.05. No? So from these two values, project this, just simply connect these 2 points. Okay, so yung intersection ng line and the x-axis represent yung next possible value of x. No? So as we compute, this turns out to be equal to 0.06461. No? So approximately location niya is nasa ito yung blue solid line. No? So for the second iteration, so we can generate this equation. So from the equation that we derive, just simply set the I value to 1. We can generate this. Okay. So similarly, we already have the value of x sub 1 as well as x sub naught. We can be able to determine f of x sub 1 by substituting this x sub 1 to the given function. Okay. And also f of x sub naught by substituting the value of x sub naught to the given function. So this will give us the value of x sub 2 as 0.06241. No? So again, we need to calculate the percent error after each iteration process. So this turns out to be the new x, okay, 0.06241. Then the previous value of x is the x sub 1, okay, over the new value of x. Then take the absolute value times 100. So this will give us around 3.5 na lang, no, from the previous percent error na, or almost 23%. So for the graphically, you can represent, okay, yung x sub 2 natin na 0.0621 as this form. Okay. For the third iteration, so same process. Okay. So this will give us, you can generate this x sub 3 formula from the equation that we derived. Just simply set the I value to 2. No? So this give us the next value of x sub 3 as 0.06238. So again, if you try to calculate the percent error, this will give us almost 0.06 lang, no, percent. So graphically, this will be our representation. So we can also tabulate our values. No? So from the first iteration up to third, we can also add another iteration. So as you can see, yung value ng x sub I plus 1 natin, okay, it's almost the same, no? 0.06238. And yung error natin is almost negligible na, no? Almost close to a zero value if you take the absolute value. So the answer here would be ito, 0.06238. So this is the value of x. Okay, any question this part, class? Before we proceed to the next method, which is the Newton-Raphson, no? Any question? Diyan po ba kayo? Hello? Any question? May sa chat? None, sir. Okay. Lagi po bang sineset as 1? It's more convenient to set as 1 kasi 1 means yung first iteration process, no? Para hindi magulo. Kasi for the first iteration, we can be able to determine x sub 1, di ba? For the second iteration, so variable naman yun. So you can use any numerical value. Okay na, another question? Okay, so for the Newton-Raphson, so this method is more efficient than the bisection and iteration method. So if x is the real root and x sub naught as the initial approximation of the real root of an equation f of x equals 0, then we have here the following assumptions. No? So kailangan yung f prime of x sub naught should not be equal to 0. And f of x is the same sign between x sub naught and x. Then the tangent at f of x sub naught can lead us to the real root of x. No? So graphically, so let's say this curve represent the behavior of a given function. So initially we have the initial guess ng root ng function. No? So we can label that as x sub naught. Okay, so from the value of x sub naught, we can be able to determine the value of f of x sub naught. Okay, so this point. So after that, you need to determine the f prime of x sub naught. So this would lead us to the next possible value of x. So we can label that as x sub 1. Okay. So the process will repeat until such time that we can be able to determine the real root of the given function. So this would lead us to the next value of x as x sub 2. Okay. So yeah. Or graphically, this will be the uh, representation. So of course, you can label this point as P, this point as T, and this point as M. No? So the tangent of PTM is the same as yung value ng segment PM over TM. So rise, rise over run, diba? Okay. And tangent of PTM is the same as since PM is the value of f of x sub naught and TM. So we can let a variable h represent this segment, no? Okay. Then tangent PTM is the same as f prime of x sub naught since this represents the slope, no? So therefore, f prime of x sub naught is equivalent to, so we simply equate this to, okay, so f of x sub naught over h. Or if we try to isolate h, excuse me, this will give us f of x sub naught over f prime of x sub naught. So from this figure, okay, we can see here that since we set this as h, okay, so yung x sub 1 natin is equivalent to x sub naught minus the h, no? Therefore, so from this equation, x sub 1 is equals to x sub naught minus, so the value of h is f of x sub naught over f prime of x sub naught. Similarly, we can generate this equation. Okay, so you can see here yung pattern. So yung pattern natin is ganito, no? So annotate right. So yung formula natin for the Newton-Raphson is x sub n plus 1 is equals to x sub n minus f of x sub n over f prime of x sub n. So this formula can also be derived using the concept of the Taylor series. No? So we will not anymore elaborate the process since we derive the formula of the Newton-Raphson using the geometry. Yan. So this formula is known as the Newton-Raphson formula. X of n plus 1 is equals to x of n minus f of x of n over f prime of x of n. Okay? So example tayo. So let's say we want to find the real root of the equation using the Newton-Raphson. So we're given here the equation f of x equals to x raised to 3 plus 4x squared minus 1. So of course we need to define what's the f prime of x, no? So let me write first yung f prime of x natin. So of course, from the given f of x, so this will give us f prime of x as 3x squared plus 8x, no? Now, using your calculator, uh, just go to the mode, then press 7 for the table. You can be able to generate here yung function table. So f of x equals to, so just enter the x raised to 3 plus 4x squared minus 1, then press the equal sign. So the starting value, so initially we can assume, okay, our set of x would be running from 0 to 10. No? So let's say 0 starting point, then press equal sign. Ending point is press 10, then press equal sign. Then the step or increment would be, let's say 1. No? So press equal sign. So this will generate a table, yung x value natin from 0 to 10, and the corresponding value of f of x. So as you can see, if you try to check yung table, so between 0 to 1, so ito yung x natin, f of x, so the value of f of x, if x is 0 is negative 1, and if x is 1, the value of f of x is 4. No? So we expect that between these two values, their corresponding value of x such that the value of f of x is 0. Okay? Tama? So we can repeat the process of iteration. Just press again the AC. So this time, our starting point is 0 and ending point is 1. No? And this time, the increment is, let's say, 0.1. So again, just press the equal sign. This will generate again a table. If you try to observe yung value, the change in sign happens between 0.4 to 0.5. So ito 0.4 296, then 0.5, 0.125. So if you try to compare these two, if you take the absolute value, so this value of f of x 0.125 is close to 0 values. That's why we can select this 0.5 as the initial guess for x. No? So we need to generate here a table. So that's why the value for the initial guess of x would be 0.5. Okay. So of course, to determine the value of f of x of n, just substitute this 0.5 to this given function. No? So this give us negative 0.125. And to determine the value of f prime of x of n, just substitute this 0.5 to this f prime of x. So this will give us 4.75. Okay. So now to obtain this last column, just simply divide this two, no? So this will give us 0.026315 and so on. Now to obtain the next value of x for the next iteration, we need to use this formula, no? So from this formula, we can see here that to obtain the next value of x, so simply subtract this 2, no? 0.5 and ito, no? yung fraction, 0.026315. So 0.5 minus this value, last column, this will give us 0.4736842105. Okay. So the process will repeat until such time that the percentage error or relative error would be around mga less than 1%. No? So if you try to continue, so again, to obtain the next column, just substitute this x value to the given function. This will give us 3.79 times 10 to the negative 3. And this one, substitute this to the f prime of x. So this will give us 4.46. Okay. And so on. And this one, just divide this two. This will give us 8.49 no? Times 10 to the negative 4. So again, to obtain the next value of x, so just subtract these two, the first and the last column. We can obtain this 0.47283477872 no. So if we try to continue the process, okay, so this will give us the following values. Then 8.7816 times 10 to the negative 7. So next value is 0.472833909. Okay. Now if we try to compare, okay, yung using the formula for the percentage error, x new minus x old over the x new, take the absolute value times 100, this will give us the percent error as 0.000186 no, percent. So this is almost close to zero value or less than 1. So this is acceptable now. So we can now state our answer as in this form. No? Ito. Point, ito yung x value. 0.472833909. No? Any question? Question so far, class? What? Clear ba? Hello? Diyan pa ba kayo?
Yes, sir.
Okay. Question, wala no? So clear ko muna to, no? Ayan. So yung sagot, if you try to continue, so almost the same, no? After fourth iteration, this will yield a value of 0.4728333909. Okay. So let's proceed now sa application, numerical methods. Okay. So by considering this problem, so let's say your task to design a spherical tank as shown in this figure to hold a water for a small village in a developing country, no? So the volume of, liquid it can hold can be computed as using this formula, no? So yung volume is function of R and H, no? So dalawa lang yung variables. So of R, of course, represent the radius, okay? And H represent yung depth, no? Now for this problem, we're given here the R value as 3 meters, no? So what depth? So ang required is the value of H, okay? Must the tank be filled so that it can hold 30 cubic meters. So this is the volume, no? So use three iterations of the Newton-Raphson method to determine your answer and determine the relative or approximate relative error after each iteration. So note that the initial guess of R will always converge. Okay, so just try to write yung given sorry, hindi pa pala nakakabit. So volume is, ito yung formula, no? 3R minus H over 3. So we're given here the R value H is unknown, volume is 30 cubic meter. Okay. So from the given, okay, so simply substitute natin. So 30, so pi h squared, 3 times 3 minus h over 3, no? So we need to express our function in terms of h. Okay. So 90 over pi equals 9h. 9h, tama ba? Squared. Parang may kulang dito. Tama. Then minus h raised 3. Okay, so we can express our f of h as in this form, h raised to 3 minus 9h squared plus 90 over pi. Okay. Of course, we need to use the Newton-Raphson, so we have to define what is f prime of h. Okay, so this is 3h squared minus 18h. Okay. So from the given figure, we can see here that the restriction for h would be what? Just twice of r, no? Since of r value is 3, so twice of that would be, of course, kasi yung twice niya is yung restriction for the diameter. So yung h value natin should be less than or equal to 6, but greater than, of course, 0, no? Now, using your calculator, okay, you can be able to generate yung table again. Just use yung mode 7, no? So if we try to inspect yung result from the table, so x, f of x, so between 2 and 3, no? Yung change yung sign. So we can assume that the initial guess for x would be simply 2 lang, no? So let's say 2.0. So we can label itong f of x. So of course, f of x of n can be obtained by substituting this 2 to this f of h, no? So this will give us 0.6478 and so on. Actually, you can save this value. Just use yung store, no, sa calculator. Okay, as let's say you can store this as b. And to obtain this f prime of x, just substitute this 2 to this f prime of h, no? So we can be able to determine yung f prime of x of n as negative 24. Let's say you save this as c. So to obtain the last fourth column, just recall, okay, yung b value, then divide mo sa, recall mo yung c value. So this will give us negative 0.0269, no? And so on. So again, to obtain the next possible value of x, so just use the formula for the Newton-Raphson. Xn minus f of x of n over f prime of x of n. So this value 2 minus this negative 0.0269. Okay, so this will give us 2.02699, no? 5407. Okay, so you can save this value actually as, let's say, a, no? So of course, to obtain f of x of n, simply recall na lang yung a, no? So a raised to 3 minus 9a squared plus 90 over pi. This will give us a value of negative 2.17 to, no? Times 10 to the negative 3. Similarly, to obtain f prime of x, so recall lang natin yung value ng a. So 3 times a squared minus 18 times a. This will give us negative 24.16 to, no? So just save this as c. So to obtain this last column, just divide b and c, no? B divided by c. This will give us 8.96, no? Or 7 times 10 to the negative 5. So you can actually save this as d, no? So to obtain the next possible value of x, apply this formula, yung Robson. So re-recall mo na lang a minus d. This will give us a value of 2.026905729. Now, if we try to check yung percent error, this is the x new, and this is the x old. So x new minus x old divided by x new. Take the absolute value times 100. So the error is around mga 0.00442. So naka-percent na yan. So almost negligible na to, no? Zero na to. So this is the value of x. So this is in meters. Okay? Or ito yung h value. So sa check, if you try to substitute this value of h to the original equation, so this is the original equation, so the value, yung volume should be around this, almost or equal to 30 cubic meter. So in checking. Question so far, class? Isa pa? Last example? Kaya pa? Oh, may question ba? Okay, so last example. So clear ko lang to, no? Okay, yeah. So the concentration of the pollutant bacteria C in the lake decreases as per the model given. So C, concentration bacteria is a function of the time, no? Ito lang yung variable. Determine the time required for the bacteria concentration to be reduced to this value 9, no? So we have to use the Newton-Raphson stopping criterion of 1%. So of course, ang time natin, this will start, wait lang. So ang time natin should be a positive value, di ba? So it should be greater than or equal to 0. So wala namang time na negative. So ang given sa atin is what? At time equals 0, so yung initial concentration is 95. So just substitute this 0 to the given equation. You can be able to determine yung value 95. And for this case, we want to determine yung value ng time such that the concentration is equal to this value 9. No? So we need to express okay, yung function natin as in terms of the variable t. So f of t natin is ito, 70e raised to 1.5t. Naglolo ko yung tablet. Okay, t, then plus 25 e raised to negative 0.075 t. Then the c value should be 9, no? So we need to transpose this c to the right. So minus 9. Kasi ang requirement that our function should be equated to 0, no? Of course, we can define what is f prime of t. So recall the derivative of e to the u is e to the u dxu, no? So this will give us 105 e raised to 1.5 t minus 1.875. So this is 8 now. Then e 0.075 times t. Okay. So again, using your calculator, uh, we can set, okay, or we can generate a table, yung x and the corresponding value of f of x now. So let's say start tayo sa 0 to 20 with an increment of 1. So if you try to observe, yung change of sign happen between 13 and 14. So it's 13.4298. So 14 naman is negative 0.251. Okay. Now if you try to select this 13 as the initial guess, so f of x, f prime of x, then f of x over f prime of xn. So 13 or if you try to uh, set another or generate another table, so let's say between 13 to 14, this time with an increment of zero point 0.1. So you found out that the change in sign happened between 13.6 and 13.7. So this is x f of x. So 0.0148, and this one is negative 0.052. So for the initial guess, we can select this 13.6. So this one 0.0148736. This one. So of course, to obtain this, just substitute this 13.6 to this f of t. So to obtain the third column, substitute this 13.6 to f prime of t. So of course, to obtain the last column, just simply divide this 2, no? So this give us 0.021998. So to obtain the next possible value of x, okay, 13.6 minus the last column. So this will give us 13.6219986. So doing the same process, we can obtain the following, no? And last one, so to obtain the next possible value of x, 13.6219 minus this value, no, negative 1.82 times 10 to the negative 5. This will give us 13.62201,677. Okay. So to compute yung error, x new minus x old over x new, take the absolute value times 100, this will give us 0.000133%. Okay. So of course, the stopping criterion is should be less than 1%, no? So this value is acceptable. So ito yung value ng time natin. So sa check, if you try to substitute this 13.62 to this given equation, the C value should be almost equal to 9. Okay? Any question? Hello? Wala? So by next meeting, so ang schedule natin is, nag-quiz na tayo? Hindi pa, no?
Iba po.
Hindi pa. So ang schedule ng quiz natin is next week. Last quiz na to, no? December 15. Okay, so yung coverage is from, I think, matrix, no? Up to this topic, application ng Newton-Raphson. Then, yung schedule ng finals will be announced by next week na lang siguro, no? Kasi ang start ng final week is, I think, 17 to 22. Okay? So, most likely, baka ang final exam natin is next week pa siguro. Okay? Either 21 or 22. Clear ko lang yung drawing? Or may question ba sa chat? Sir, ask ko lang po bakit nag-start ng 13. Kasi, so from the table kasi, ang aim natin is to find the value of x such that the value of f of x is 0. So either you can use the 13 or 14 value. Okay? Anyway, magko-converge naman siya to the same value of x, which is 13.62. Kasi pag ginamit mo, let's say, a value which is far from the real value of x, mas maraming iteration process, no? Anyway, this will give us the same value. So, nag-start lang tayo sa 13 so that we can minimize the number of iteration. Okay na? Another concern, question? So, clear ko na yung drawing. Then, paano ba stop? Stop record.